so I believe that's noon. So we're going to go ahead and get started. No questions in the chat box, so I guess we're all good to go here. We're doing sections 14 and 15 today, which means we are in Module 8. The beauty of Module 8 is that next week is spring break, so we can all celebrate, take a week off. You can work ahead if you're really motivated, or you can just relax for a little bit, which is always nice. So 2 sections this week. Shannon, I feel the same way. Yes, I'm very excited. I'm actually moving on Monday, so I'm going to be spending my break. I'm going to a math conference, and I'm moving. So not much of a break, but at least I don't have to also work, so that is nice. Okay, anyway. So 2 sections this week, 14 and 15, and the nice thing about these sections is that they're related. So you're going to see kind of a common theme between the two. And while they're similar, they're still different enough that you're going to need to pay attention. Then we have our weekly quiz and our weekly discussion board. You're going to Mexico for three weeks? Well, now I'm jealous. But if you're going for 3 weeks, that means you have to work while you're there. You know, at least do a little bit of math, hopefully. That's not always so good. But nice. So I do hope that you guys have some time over spring break where you can relax a little bit, because I think that is necessary to let your brain take a break, especially because you've been doing a lot in this class. Project 2 was assigned last week. I don't know if any of you have started that. We had a discussion board where you talked about appliances that you're going to use. I don't think I have any videos for that. I know I didn't post any for you. I'm going to double check, but I don't think I do. If I do, I will post them today as well. Otherwise, you're going to have to kind of fumble through on your own. Email me with questions. I'm about halfway through grading Project 1. They'll all be graded by Friday. And, some are very good and some have missed the mark a little bit. So, make sure as you're working, if something doesn't make sense, if you think, you might be wrong, whatever, just shoot me an email. Of course, you need to start it before the day it's due in order to have time for a question-answer conversation. So don't wait until the very end to start Project 2. Because you want to get as many points as you can from these things. So, but other than that, in terms of workload for this week, it's pretty light. 2 work sections, a quiz and a discussion board. That's pretty light compared to some of our weeks. So that's pretty good. All right, so let's go ahead and jump in and see what all of this is about. So section 14 gets us into the normal distribution. And if you recall in section 13, we did histograms and such, where we talked about, when we had histograms with continuous data, we talked about skewness a little bit. So, and we did that also in section 8. So remember, we talked about being right skewed, we talked about being left skewed. Well, the normal distribution says, you know what, forget all skewness, and let's go to symmetry. Okay, so again, bear with me, I'm writing with, a mouse. But the normal distribution is based off of this beautiful bell-shaped curve, right? Symmetry. And the big thing about this, change colors, is that if we pretend, oh my gosh, look how straight that line is. I should just stop right now because it's not going to get any better than that. If we put a straight line down the middle and we fold the left and the right half, right, they should be the same. Now, obviously, my drawing is horrible, but with the normal distribution and the bell curve, we will have symmetrical data. Now, this line right down the middle, this represents the mean. It also represents the median and the mode, but for our purposes in this section, we're only really concerned about the mean. So one thing just to also be aware of, the area under the curve, all of this stuff underneath here is 100% of your data, right? Everything fills it up is 100%. So also this area underneath here, that 100%, we talk about the area under the curve. Man, I cannot write as fast as I can talk. Oops. Area under the curve is the same thing as probability. So we'll be able to, take chunks of this and say if we know the certain percentage in this chunk, and that percentage would represent a probability. And that's kind of the purpose of today, is we are going to use this normal distribution to answer some probability questions. And we're going to do that differently in sections 14 versus section 15. Again, similar, but different. So one other thing that we need to bring up here in this section is the idea of standard deviation. Now, standard deviation is signified by a lowercase sigma. Okay, so this is standard deviation. And standard deviation is basically how far away a value is from the mean. So if I had 10 numbers in a data set, we found the mean and the standard deviation would talk about the typical distance from the mean of one of the values of numbers. And, sometimes I think when I just talk about math, it doesn't make a lot of sense. So hopefully as we work through sections 14 and 15, you're going to see where the standard deviation comes in and the definition of it, of how it really represents the distance from the mean, how that makes sense. Okay, but one thing that I want to give you a pictorial view. These are both normal distribution curves. Very different in terms of looks, right? We know that the mean is right down the middle in both of these. Now, what I was trying to get at is we'll call this one A, we'll call this one B just for reference. In normal distribution curve A, you can see that I would describe that as tall and skinny. The majority of the data is very close to the mean, right? So if it's tall and skinny and your data is really clustered around the mean, we would say that this has a small standard deviation. So when you graph your data, it would all be clustered around the mean. Whereas in figure B, you can see how it's really spread out. It's short and fat, and therefore we would say this one would have a larger standard deviation. So if you're looking at the graphics of two things, the more data that is around your mean, the smaller your standard deviation. So if I was talking about test scores from exam 1, talking about my face-to-face classes, my evening class had a standard deviation of 7. My morning class had a standard deviation of 15. And these pictures, these drawings, figures, whatever you want to call them, would be decent representations of what that means, right? If the standard deviation is 7, that means the majority of students were clustered closer to the mean than in my morning class, where it had a larger standard deviation. It was more spread out. Okay, so that's pictorially what the standard deviation looks like. I think we're ready to get into the empirical rule. Now, I'm not going to spend a ton of time on the empirical rule. I have a 4-minute video that will explain where every number comes from. So after we're done today, if you're like, you know what, I want to spend 4 minutes and understand where these numbers come from, I'm going to post that in the same announcement where I post the live session, and that may help. But the empirical rule is also sometimes known as the 68, 95, 99.7% rule. Right? These are all percents. And these talk about the percentage of data that falls within 1, 2, or 3 standard deviations of the mean. Now, math people are not creative, so 68% would represent 1 standard deviation from the mean, 95 would represent 2, and 99.7 would represent 3 standard deviations from the mean. So pictorially, and again, this is very hard to do on here because, there's not much room. I can't extend on my paper, blah, 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 whatever. So mathematically, I'm going to do just a quick example. This is not as in-depth as the one in the video, but basically the mean is in the middle, right? And I just put up here that my mean is 70, right? The mean is 70, the standard deviation is 5. What the empirical rule says is that 68% of my data will be within 1 standard deviation of the mean. So if I go 1 standard deviation on each side, 1 standard deviation is 5 units. So if I go to the right, my value is 75. If I go to the left, my value is 65. So this is 68%. Well, remember that the pink line splits the entire thing in half. So if I take 68 and I split it in half, I end up with 34%. Okay. In an effort of time, I'm not going to show you all of the tricks and the trades of this because, again, you can watch the video. You have the ability. But if we go out, we would have 80 and 60. These numbers are 13.5. We would go out one more, right? That's 95%. So 95% of your data falls between 60 and 80. And then we'd go out one more and say 85 and 55. These values are 2.35%. These are all percents, by the way, in here. And then, so 99%, right? 3 standard deviations. is 55 to 85, and that's 99.7% of our data. Now you'll notice we said earlier that the entire curve is 100%, but from 55 to 85 only represents 99.7% of the data. So we have 0.3% that is left over in the two tails. So if we look at the tails are here. Well, if you take 0.3 and divide by 2, that puts 0.15% in each one of the tails. We call that highly unusual, right? It's a very, very small percent. So again, if you watch the video, it will describe how each of these numbers comes to be and why it is there and why it makes sense mathematically. Okay, now the purpose of this. So we have our mean of 70 here in the middle, and then we added 5 to the right. We subtracted 5 to the left because 5 was our standard deviation. This allows us to say, what is the probability a student would score between 80 and 85? Well, if we want to go between 80 and 85, the probability would be 2.35%. So the empirical rule gives us a very quick glimpse of probability for certain values. And that is the whole purpose of it. All right, so that's a very quick run through. If you need, and there, I don't remember what page this is on in your workbook, but they don't really explain where the numbers come from, but they do have a graphic of all the percentages. We're going to need those on the next example. So page 122 would be good to have open for a bit because it has the percentages of the empirical rule, because I'm going to delete these and we're going to go on to the next question. Okay, so for the next 5 slides, these are the questions that we are going to answer. And we're pretty much going to do them together, at least for a bit. So the average miles per gallon in luxury cars is 29 with a standard deviation of 3. Okay, so we know our mean. We know our standard deviation. That's important. So from using that information, we are going to draw the curve and label all of those numbers at the bottom. Then we're going to answer some probability questions about it. Okay, so this is going to be interesting of how we get this done, but we're going to get it done. All right, so hopefully we're going to find less than 23, more than 23, between 20 and 32, and more than 38. Because this is, I'm not going to be able to redraw the picture every time. We won't have time. So hopefully you draw the picture and we'll be able to answer from there. Okay? All right, let's see what we can do. Erase these drawings, move to the next page. Okay, so the first step is to draw the curve. Where's my pen? There it is. Another straight line today. It's going to be a good day. We got our curve, and we want to put the numbers in, right? So you think, where do we start with this? Let me ask a question for the first time in a minute. Where are we going to start? I tried to give you a hint. Very good, Noah. We always start with the mean. When you're working on normal distribution curves and the empirical rule, you have to start with your mean. So we know our mean is what? Anybody remember from that last page? 29. Thank you. And what's our standard deviation, just for reference? 3. Good. Thank goodness you guys are paying attention. Okay, so we start with our mean in the middle. And I recommend when you get to web work and you're doing these problems, take the 20 seconds it's going to take you, sketch one of these curves, put your percents in, put the numbers at the bottom. It's going to make the problems go so much easier because you don't have to imagine where things are. You just have to look, right? So what are my values for the green? What's the value on the left going to be? 26, very good, because we subtract the standard deviation. So 29 minus 3 is 26. And on the right side, we have 32. Very good. So that's 68% of our data. Okay, let me go ahead and throw those in. Okay, then we go out the next ones. So I should have, what are the two values there? 23, good, and 35. Well done. So that's 95%. From 23 to 35 is 95%. All right, we go out one more time. What are those values? 20 and 38. Very good. Okay, so hopefully you have this written down. Oops. And again, all of these numbers inside are percents. I do not have percent signs because I'm a horrible person, but they are all percents. Okay, so this is what we are going to use now to answer the next 4 questions. And I'm going to draw abbreviated one of these. Man, I can't talk. But it'll help if you have the whole thing written down that you can reference for your own self. Okay. Everybody good? Okay, and I want to erase it when people are still writing because I know that's frustrating. So I'm just going to wait a few more seconds so people can write, and we're done. Okay, so now we're going to talk about getting less or more than 23. Okay, so recall that 23 was over here, right? This is what I say by abbreviate. Screenshot, brilliant. That's a very good idea, actually. Okay, so 23 is somewhere over here. For part B, we're going to answer that first in yellow. It says probability a car gets less than 23. Which, man, you guys are definitely smarter than me. I never thought about screenshotting. Probability a car gets less than 23. Which direction means less? To the left. Very good. So we want to know all of this over here. So when you look at either your screenshot or your drawing, add up all of the percents that are to the left of 23. And what do you get? %2.5%. Very good. Because you had the 2.35 and you had the 0.15. So because we want everything to that side of 23, we add those two together. And that gives us 2.5%. So the probability a car gets less than 23 miles per gallon is 2.5%. Stop me if you have questions or if something doesn't make sense. So now we're going to move on to part C, which says more than 23. So we're going to stick on this page. Now, more than 23 goes this direction. There are 2 ways to find this, right? One is to just add all of these together. Add these percents, all of them on this side. What's the other way? That's quicker and easier, less work. Exactly. Very, very good. You know the whole thing is 100. So if we subtract the amount to the left, the rest is the amount to the right. And this is the idea of complements, which is probability, which is section 16 as well. So when we come back from spring break, we're going to have more of that, which is fabulous. All right, so the probability of a car getting more than 23 miles per gallon is 97.5%. Okay. Hopefully, so far, this is making sense. Now let's look at the probability of car gets between 20 and 32. That's a horrible graph, but it'll work. So 20 is way over here, and 32 was about right here. So if we want between 20 and 32, we're looking for the area between those 2 spots. Right, so you're going to add all the percentages between those 2. $83.85, 85.85. Why do we have multiple answers? Okay, thank you. I was like, 83.85%. Does everybody agree with that? That's what you guys all have written down. For some reason, I don't have this answer written down, so I got to go with you guys. Yeah, but we did add them all together, right? So this one's 34, so 68, and you have a 2.35. Yeah, that makes sense. Very good. Okay, any questions on, well, wait, I lied, we have one more. sorry, more than 38. So here's my picture. I know 38 is somewhere over here. We go to the right, and there it is, 0.15%. Yep. But do you see how the picture can be very, very helpful? That you locate what you're looking for, and there it is. Yeah. Okay, questions on any of that A through E? It's not bad at all. No. So I do, now that we're on, wrong button. Okay, so we're done. That's a straight line, but not through the words. Okay, so we have just done our example that we're doing for section 14 with the empirical rule. And it's not bad, right? You draw the picture, you put the lines in, and then you can answer your probability questions. But the issue is this. Okay, you ready? Just real quick, the numbers that we just had, 29, then we had 32, 35, pardon my handwriting, but you guys already have all this written down, 26, 23, and 20. My guess is most of you have a car, and if you don't, you know somebody who does. Is it only possible to get these 7 miles per gallon in a car? Exactly. So if you said, well, my favorite number is, 25. So I want to know what's probability my car is going to get more than 25 miles per gallon. The downfall of the empirical rule is that you are locked in to 7 numbers. If you want to find out about 25, well, you have to just round to 26 to be able to use this. You have to use whatever is close because you only have 7 numbers. And that is the basic problem with the empirical rule. It's pretty easy. It's pretty straightforward. Okay, I'll go with that. Yeah. So it's, and the whole 68, 95, 99.7 is also disputed in statistics. There's a couple other different ways to think about where data falls. So it's a quick way to kind of get through, and it's really good to just start understanding the normal distribution. That's really what the empirical rule is good for, is to really start understanding the curve, how it relates, probability, all of those things. So the fact, if you understood that example, all 5 parts of it, how the pieces fit together, how it went from one side to the other, that's good. That's what we want to get out of section 14. All right. Does anybody have any other questions about section 14? Okay. One thing I do need to throw at you. You are going to be asked to use Excel for a couple of the web work problems. And you don't have to you will never have to calculate standard deviation by hand. It is a very ugly formula by hand, but you will need to use Excel or sheets or numbers, right? One of those spreadsheet pieces. But in Excel, so for Excel, when you're going to use standard deviation, you want to use the formula STET dev S. It is very, very, very important that you use S. S stands for sample. There's also a STET dev P. P stands for population. But we always deal with samples in our class, right? Sample is a part of a population. Since we don't deal with all the data, we can't calculate it as all. So your answers will be slightly different if you use the S or the P. So you want to use STET dev S when you use Excel for these problems. And again, if you have any questions, shoot me an email and I will answer that as quickly as possible. I will not be emailing much, if at all, over spring break, so just consider yourself warned. It's spring break for a reason, right? So, okay, that's section 14, the normal distribution, the intro to that. And now we are on to Z-scores. So before, hey, if I would have turned my page on my notes, I had all the answers written down. But I didn't, so I didn't even know. Okay, so section 15, you are going to need your yellow sheet for this eventually. So that page 245, 246 formula sheet that we use in sections 10 and 11, if you turn it to the back on page 246, the top part of that we are going to be using here shortly. So just have that, dig it out, if you will, because we're going to need that. So Z-scores. By definition, a z-score is, so this is the definition of a z-score, the number of standard deviations from the mean. So how far away are you from the mean? So for instance, if I say I have a z-score of 1.5, notice it's positive. That means I am 1.5 standard deviations. It's positive, so I am above the mean. If I have a z-score of -2, that means I am 2 standard deviations. It's negative, so I would be below the mean. So when you're looking at a data value, if it's bigger than the average, then you have a positive z-score. If you have a value and it's lower than the mean, then you're going to have a negative z-score. That's how it works always. So it totally depends on your data values and the mean and how they relate. But that's just the definition of a z-score. Now the purpose of a z-score is to standardize data. So just a quick story. When I did my dissertation, I was looking at test scores from a number of years, and some students had taken the AccuPlacer and some had taken Compass, right? Two very different tests with very different grading, very different numbers, but I needed them to be in one data set. So I took all of the AccuPlacer scores and found the average and the standard deviation, and I turned them into z-scores. Then I went to the Compass grades, and I found the mean of them and the standard deviation, and I turned them all into z-scores. So now, instead of having two different grading patterns, I had all z-scores. Then I could treat them all the same. So z-scores are a way to standardize data and made it good. Brooke, yes. So I would say, like, if your z-score is 1.5, this arrow is like then your data point is 1.5 standard deviations above the mean. Yeah, that it's an arrow is what this is. Yeah. So that's just kind of how we talk about the meaning of it. If your z-score would just be a 1, then you are 1 standard deviation above the mean. The big thing to remember is that positive is always above the mean and negative is always below the mean. That's just a quick way for you to check whether or not your z-score makes sense with the value that you started with. And we're going to do examples, of course. So hopefully this will all make more sense as we kind of go through examples. So any other questions? Thanks for the question, though. Any other questions on just the definition page in my little story time? Going once, going twice. Okay, let's get into it. So the formula. You see the symbols, and if you look at that yellow sheet on page 246, right underneath, that big table at the top, you see the formula, z equals x minus mu over sigma. And that formula is only useful if you know what those pieces mean. So x represents your data value. So it's whatever value is in question. I'm trying to figure out. So in our section 14 problems, we were talking about, less than 23 miles per gallon. Well, 23 would have been our data point. Okay, our data value. Mu, which is a fancy looking M. Some people think it looks like a U. That's the mean. So the fancy M is the mean. And I already told you that the curly Q there, the sigma, is the standard deviation. And hopefully it goes without saying that the Z stands for the Z-score. Right. Now you can also manipulate this equation. If you start with a Z-score, you can work backwards to find your data value or your mean or anything else, depending on what you have. Okay, so now your table. I want to talk about the table before we actually get into a problem with it, because we're going to find Z-scores using this formula in just a minute, and we're going to use that table here in just a minute. So first things first. I'm going to draw this beautiful piece, and I'm going to say I have a z-score of 1. Okay. Now, a z-score of 1 simply means I am 1 standard deviation above the mean, right? Because we know the mean is directly in the middle. So just for fun, can anybody tell me what the z-score is for the mean? If a z-score of 1 means I am 1 standard deviation above the mean, what would be the z-score for the mean? Shannon, you're absolutely correct. The z-score for the mean would be 0. So if you think about this as a number line, your mean is in the middle at 0, and then your standard deviation, or your z-scores represent the number of standard deviations away. Positive to the right, negative to the left, because you're either above the mean or you're below the mean. Very good. And we're going to show mathematically why that's true, why that 0 is true. But if I go back and I want to say, I want to know, back to my z-score of 1, I want to know the probability of being less than that. Okay, so everybody look at page 246. You've got 4 columns, where each column, inside each column has 2 columns. So you're looking to find a z-score of positive 1, which is in the 3rd column at the very bottom. What number does your table give you for a z-score of 1? Good. So 0.8413. Does everybody see that? And if you don't have your sheet with you, it's kind of difficult, but hopefully go back and check later. Okay, so the thing to remember is that the table always gives you area to the left. Always. So when you're finding z equals 1, so z-score of 1, the probability next to it is the area to the left. And that should make sense. 0.8413 is greater than half, and you can see, right, that mean is the halfway point, so the shaded blue is definitely more than half. So logically, that should make sense. Now, I want to ask you one more question. Now that I have 0.8413 written down, I no longer need my table for the next question, because I want to know the probability of greater than a z-score of 1. How do I find the gray shaded region from the information I have? Anybody have any idea? We already talked about this a little bit from section 4. No, it's not -1. We're still using a z-score of 1. We're just finding the area to the right. Think about the picture that I so beautifully drew. What do you know about the whole thing? There you go, Amanda. Very good. The whole thing is 100%, right? Well, we're now dealing with decimals, not percent. So 100% as a decimal is just 1. So if the whole thing is 1, and I subtract the area to the left, then that gives me the area to the right, which would be 0.1587. So you'd really just have to remember that the table tells me to the left. So if I want area to the right, I just have to subtract from 1. And then I will have the area to the right. Because together, if I'm using this vertical spot as my, boundary line, the space on the left and the space on the right together have to add up to the whole thing. Right? I've only broken it into 2 pieces, left and right. So together they have to be 100%, or in this case as a decimal, 1. Okay. All right, so that's kind of a background. Now let's actually use this formula, and we'll get to our table here in just a moment. Okay. So we are going to use the average calories burned at the gym is 460, so that's our mean. Standard deviation of 35. We are going to use those values for the next couple slides. So if you could jot those down, that would be great. Yeah, and Noah, you're going to find, I think everybody will find this, that the first couple problems you do is going to be a little bit like you're swimming through mud. But really, it usually only takes maybe 2 or 3, and then you're cooking with gas. So it really just, once you get the hang of it, it's one of those things that once you get it, you got it. Sometimes it just takes a little bit for it to all oil up and make sense. All right, so we're given the mean and the standard deviation. And our first question just simply says, what is the z-score of somebody who burns 510 calories? So first, remember your formula. Value minus the mean divided by the standard deviation. Now, if you are a details person, if you like to make sure you have everything written down first, right, we're trying to find the z-score. That means I should have x, mu, and sigma given to me. So sometimes it might be good to just get those things written down first. So what is the value that I'm going to use for x? What is my data value in this problem? 510, very good. right? We're burning 510 calories, so there's my data value. What's my mean? 460. And the standard deviation, 35. Look, 3 different people answered that. That was fabulous. Okay, so now when I go to plug them in, my z-score is x minus the mean divided by the standard deviation. Now, depending on your calculator and depending on if you're using Excel, you may want to put your numerator in parentheses. Because if you just type it in as you see it, some calculators will give you a very, very wrong answer. Okay? Oh, excuse me. So you might want to put those in parentheses before you throw them in. Well, Shannon, we're going to draw a graph on the next page. So you're good. The reason we're not drawing a graph on this one is because it's not directly on, we'll get to that on the next page. There's nothing wrong with drawing a graph. Do not make that sad face. You're good. So first we're just finding the z-score. When we're finding the z-score, that's just the formula. So you can either type it in all at one time, or you can say 510 minus 460 is 50. And when I take 50 divided by 35, what does your calculator spit at you? 1.43. Okay. It's positive. That should make sense because 510 is bigger than the mean. So if it's bigger than the mean, that means it falls to the right. It's positive. So this means, this z-score means that this person who burns 510 calories is 1.43 standard deviations above the mean. That's all it means. Okay? All right. Now, if you recall, Shannon, this is for you, but everybody will benefit. Back when we did the empirical rule, we had the mean. We had 1 standard deviation, 2 standard deviation, 3. And this way we went 1 standard deviation, 2 standard deviation, 3 standard deviations. There was no place for 1.43 in the empirical rule. With the empirical rule, you had to be 1, 2, or 3 away on either side. That's a downfall of the empirical rule. So z-scores allow us to find probability when we have z-scores of like 1.43. Right? Okay, so we have our z-score. This is going to guide us into the next question where all of those visuals and graphs are going to be helpful. Okay, so this next question says, what is the probability of someone burning less than 510 calories? Okay, if you want to find probability, you have to have a z-score. Okay, at least when we're talking about these things. We know that we just found a z-score of 1.43. Right? Everybody with me? We just did that on the previous page. And a lot of times these questions will be all together. I split them up so that we can have conversation. Okay, so when you draw your picture, because I agree, visuals are super helpful with this. A z-score of 1.43 or 510, either one, it's going to fall somewhere over here. Right? So this is my z-score of 1.43. Now the question says burning less. Which direction is less? To the left. So we want to find all of this. Okay, pull out your yellow sheet. You will notice 1.43 is not on your yellow sheet. So what value might you have to use? Because you're going to have to round. 1.4, exactly. So you're just going to use whatever's close. And this is one, I mean, if you had used 1.5, I wouldn't say you're wrong. You can use whatever you want, just whatever's closest. So when you're taking the exam, you may want to put on your scrap paper exactly what you're using. That way I can make sure to give you credit. Because if you go the opposite way, it doesn't mean you're wrong. It means you went a different way. I want to make sure I can give you credit back for that. Okay, anyway, so you look up 1.4 on your sheet. We're going to the left. So what is my answer for probability of burning less than 510 calories? It is not 98.6. Find the z-score of 1.4. What value is given next to the z-score of 1.4? Don't overthink this. Once you have the z-score, you simply go to the chart, find 1.4, look at the number. There we go. Good job, Julie. So then we have 0.9192. And that's our answer because we just wanted area to the left. And the table gives us area to the left. Okay? Again, the more you do these, the easier they get. Because it is a little bit, it's a different way of thinking there for a bit. Okay, now when we look at letter C, we're still dealing with 510 calories, which means we're still dealing with the same z-score of 1.4. Now, we just found that the area on this side is 0.9192. This question says probability of burning more than 510 calories. So more than that means we want this side. How do we do that? We subtract. Very good. So I take 1 minus 0.9192, and I end up with 0.0808. Yep. You definitely are going to want to read the directions about rounding in this section. You notice that the table gives you everything to 4 decimal places. Sometimes WebWork wants all 4, sometimes WebWork only wants 3. Make sure you read the directions for rounding, because otherwise it'll count you wrong and you're going to get frustrated because you know how to do it, but it's counting you wrong. So read the directions. Thanks, Vanessa, for rounding in your answer, so that prompted me to remember that. I appreciate it. Okay, questions on that one? I think it's time for you guys to try one of these on your own. I have a load of YouTube videos. Are you not watching the YouTube videos now? Okay, time out. We have to have a poll here. And okay, you are. Whew. I was like, there are videos that go with every section there. Okay, good. Because I don't know how you could do this class online without watching the videos, because there's nothing in the workbook. It's just blank crap, right? So you got to have something to help you. Good. Okay, thank you. Sorry. So then Amanda, let's go back to your first questions. Do you want, like, in addition to the normal ones?
No, I guess what I'm asking.
Yeah.
What I'm asking is, do you have them on this? I'm sorry, on this specifically that we can go over and over, because I'm still a little overwhelmed.
So you're saying, okay, so there are videos that go with section 15. So there's more of what we're doing right now.
Yes.
But at any point in time, so let's say you're done with today, you go home, you watch all the section 15 videos, and you're like, I need more practice with this. If you send me an email, because like these problems, I can come up with these problems in under a minute. It does not take long. And I can create a video almost as quickly. So if you send and say, hey, I can create a worksheet with 5 problems, email you the worksheet and the link to the video. It might take me 35 minutes total. So if you get to a section where the videos that we already have for the section aren't enough and you want more practice, let me know. And if you want like a worksheet to go with it so you can work them out, let me know and I can send that with it. Or I can just make a video with random problems and you can pause and go as you want. So
okay, thank you.
Yeah, just let me know. But yeah, Crystal makes a good point too. If you go into so there are WebWork videos, right? You guys have found those. Some of the WebWork videos I have made, but for some reason they have not been put into WebWork. I send it to our WebWork guy and he puts them in on his own time. So Crystal makes a good point. If you go into YouTube, go to my page, right? Just type in Becky Moening. It'll take you to my page. You can type in like homework 15 number 6. And now WebWork has changed over the years, so some of them may not come up exactly right. But you can just go to my page and Google things, and more videos will pop up than what's available in the course. So that is another way to do that. But I mean, I have my iPad with me all the time. It's one of those that's connected to the Verizon I'm on Verizon all the time. So even if I'm in an airport with no Wi-Fi, I have Wi-Fi because I have my iPad. So I can pretty much keep up with you and help you out whenever, wherever. Because remember, I look good when you guys are successful. So I want to, if you need an extra video, you let me know and I'll get it made. Okay, you just gotta ask. Good. Good conversation there. Good sidebar. Okay, let's have you guys try this one. Okay, so you're going to have to start with finding a z-score and then find the probability. So same gym, same standard deviation, but different calorie burnage. All right, I'm going to give you like a minute or so. See what you can do. Noah, that's almost your z-score, but not quite. And remember, the final question is probability. So after the z-score, you should be finding the probability, but you need to go back and recheck your formula. You've got something wrong with your formula. Diana, that's a good answer. Yes, Noah, those numbers were, yep, there you go. There you go. So the thing about these problems is that it's a process, and it's not just one quick thing and you're done. And that's why, you do the first step, go back and read the question and see if it makes sense. Okay, we're gonna start chatting. So when you read this problem and you say, what is the probability? That should spark that, if it works nicely, you could use the empirical rule. But 400 from 460 is 60, and that's not divisible by 35. So I know right away I'm not on one of the standard deviations. It doesn't work. If that doesn't make sense, that's okay. But you always, no matter what, you can always use z-scores, right? Value minus the mean divided by the standard deviation. So what is my value in this problem? 400, right? Because this is the mean and this is the standard deviation. So the number in question is the value, and that's 400. So we're taking 400 minus 460, and 400 is less than the mean. So right there, you should know that my z-score is going to be negative. All right, so what does that give you for a z-score? Negative 1.7. Good. And I just stopped at negative 1.7 because that's all that's going to show up on my screen or my document. If you would take a purely statistics course, your z-score table is more like 2 solid pages, maybe even more. And it's got all kinds of different decimals, blah, 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 blah. It's super, super intense compared to this half-page thing we're using. Just FYI. Okay, so a z-score of negative 1.7 falls somewhere over here. We want to burn less than that, so which direction are we going? To the left. And as a few people had typed in the chat box, we should get 0.0446. Okay. That way. Who wrote that? Noah. Nice. Okay, did that make sense to everybody? The big thing is you can see how they're similar, right? Sections 14 and 15, they're both finding probability. They're both using these curves. We're looking left, right, blah, blah, blah. 15 has a little bit more involved because you have to find the z-score first, but it's not too bad. Okay, I just have one more problem I would like to do, and this one is a little bit different. So I would like to do this one with you. The average calories burned at the gym, 460, standard deviation of 35. That's not changing. But now we're going to talk about the probability someone burns between 440 and 500. So if I'm drawing my picture here, I know that 460 is the mean, so that's like in the middle. 440 is going to be about right here, and 500 is going to be right here. I want to find this space in the middle. So this is a little bit different. Again, we want to find probability. So what is our first step, no matter what? What we got to do first? Yep, formula. Formula to do what? Because in math, there's a lot of formulas. Okay, for a minute, I thought you were sleeping. Yeah, we got to find the z-score. So we got to find the z-score for both of these. So z-score for 440 minus 460 divided by 35, and the z-score for 500 minus 460 divided by 35. And you'll notice when your z-scores start with a 0 in front of the decimal point, according to your table, you can go to 2 decimal places. But when they start with a 1 or a 2, or a 3 for that matter, you can only have 1 decimal place. Which seems odd. Shannon, I like the 1.1. I do not like the negative 1.7. Not really sure. I think you used 400 instead of 440. Because you got the same z-score that we did before. Vanessa? Oh, yes, 0.57. Well, it should be a negative 0.57, right? So this comes out to be a negative 0.57. But if you look at your document, right, you don't have 0.57. You either have 0.55 or 0.6. So it really doesn't matter. I mean, technically 0.55 is closer, but Shannon put in negative 0.6. So let's go ahead and just use negative 0.6. I don't care. They're both close. We're rounding. All right, so we found the z-scores. Now, there is no way from the table that we have to find just the space in the middle. So I want to kind of talk through how this works. All right, and I'm going to use color coding, so hopefully this makes sense. Okay, if I go to 1.1, 1.1 on the table will give me everything from this spot all the way to the left, right? This entire gray line. What is the area to the left of 1.1? Good. So that area in gray is 0.8643. So that's the yellow area we care about, but it's also all of this empty blue area we don't care about. So that's a little bit of a problem. However, if we start here at negative 0.6 and go left, there's the overlap, right? So it's the stuff the gray is the stuff I care about and a bunch of crap I don't. The orange is just the crap I don't. So what is the area to the left of negative 0.6? 0.2743. Does anybody see where we're going with this? I've got the crap that I care about in yellow. I'm color coding. And then I have a bunch of crap that I don't care about. Then in orange, I also have crap I don't care about. So numerically, right, where these two are equal, look at them. They're the same. They're the same space. So mathematically, if I subtract, these cancel out, and I'm left with just that yellow piece that I care about. Amanda, what's negative? The z-score is negative, but area is never negative. Only the z-score would be negative. And then, yeah, Shannon, so they answer, when you subtract those two, 0.8643 minus 0.2743 gives us 0.59. So that 0.59 is the space we care about in the middle. The area under the curve will always be positive. No matter what your z-score is, area is always positive. Yeah, always, always. Your z-score just tells you whether or not you're right or left of the mean. It just gives you the direction of where you're falling in terms of the graphic. That's what a z-score tells you how far you are from the mean. That's about it. Okay, this last question here, number 11, is by far the hardest thing you're going to see in this section, one where you have to maybe subtract. I don't even know if you have any of these in the web work. I usually just like to throw one in because it's a good thought process, makes you think a little bit, takes the stuff that we've done and puts it into an application type problem. So, all right, that's the end. We have 4 minutes left. Does anybody have any questions for me? If not, feel free to go off and prosper. I will be posting this live video along with, remember I said I would post that empirical rule video in case you wanted to see more of how those numbers came to be. And I will look on my YouTube page to see if I have a video to go with that CO2 project. I may have made one in a previous semester, and if I did, I'll post it. I'll give that its own announcement if I can find one. So, any other questions for the good of the group? Or for the good of you. It doesn't have to be the good of the group. But all right, keep working hard. I thank you for all the hard work that you are putting in. Make sure you're doing the discussion boards, right? Those are easy points. So get to those, get those done. And if you have any questions as you're working through things, don't hesitate to email me. And we will go from there. Oh, thank you, Noah. That's very nice. I appreciate it. Correct. Yes, there is no live session next week because of spring break. So, yeah, I will be traveling. I'm going to DC on Wednesday for a math conference. So I definitely can't, I'm not available. But yeah, you have next week off. You can work ahead if you want, but you certainly don't have to. So yeah, you can kind of take it easy. You could get your project done. That would be nice. Get that off your mind. But yeah. Any other questions? All right. Thank you, everybody. Have a fabulous week. Enjoy spring break next week. And of course, as always, let me know how I can help you. See you guys later.